Okay, let's take a look at the 2018 Leaving Cert Higher Level Paper 1 Question 2. This particular question is a probability and stats question, looking mainly at the normal distribution. Okay, so question 2, part A. The diagram shows a standard normal curve. The shaded area represents 67% of the data. Find the value of Z1. Alright, so we know that this shaded region right here contains 67% of the data. So in other words, the area of that region would be 0.67. And we're trying to find the Z value that gives you an area of 0.67. So we go to the log tables and we try to search for 0.67. Now, this particular one I'm looking at, these are all, that's 0.5040. This is 0.580. So there's a decimal point before each of these figures. So we're trying to find 0.67. So basically 0.67 is here. This is my 0.67. All right. And therefore the associated Z value is 0.44. So the Z value in this case is 0.44. So this one's fairly straightforward. Z equals 0.44. Okay, moving along. Part B. The percentage results in a maths exam for a class had a mean mark of 70. And remember, our symbol for the mean is mu in this case, with a standard deviation of 15, and the symbol for standard deviation is sigma. The percentage results in an English exam for the same class had a mean mark of 72, so mu is 72, and standard deviation, so sigma is 10. The results in both exams were normally distributed. Mary got 65 in maths and 68 in English. In which exam did Mary do better relative to the other students? So we just have to split this up into the two situations. We have maths and we have English. So what we'll do is we can calculate based on the mean and the standard deviation and her results what percent of the class would have gotten less than her. So that's what we're going to do. So first of all, we have to calculate the Z values. Remember, you have your Z value formula. Z is equals to X minus mu over sigma. All right, so in maths, when we calculate it, we've got Z is equals to, so X minus mu. X is the result she got, so 65 minus mu minus her average minus 70 over sigma over the standard deviation over 15. And that equals minus 0.33. And then in English, same formula, Z equals X, which is 68 minus mu minus 72 all over 10. And when we work that out, we get minus 0.4. So technically we already know the answer. She did better in maths because the Z value is higher than in English. But we'll draw the curve just to illustrate that even a little bit further. So minus 0.33. So remembering that 0 is in the middle, minus 0.33 is here. So this many people did worse than her. All right. And then minus 0.4 is slightly further to the left than minus 0.33. So we weren't really asked to calculate what percentage of students did worse than her, but clearly she did better in this test because there is a bigger area below minus 0.33 than there is below minus 0.4. Now what we can do is we can go ahead and calculate those areas from the Z tables if we want, but we actually don't have to because we're just comparing them. So we know she did better in maths, but just to take that a little bit further, I will calculate the areas as well. Okay. So for minus 0.33, we'll go to our log tables. So we go to 0.3 and 3. So 0.6293 would be the interesting area. So the area we care about is that area there will be 1 minus 0.6293. So the answer to that area, therefore, is going to be 0.3707. And then similarly, we look it up for minus 0.4. So 0.4, 0.6554, 0.6554. So that right there will be 1 minus 0.6554. And the answer in that case would be 0.3446. So you can look at this as, in maths, Mary did better than 37% of the students, and in English, Mary did better than 34% of the students. So relatively, she did better in maths. So the answer in that case is she did better in maths. Part 2, in English, the top 15% of students were awarded an A grade. Find the least whole number mark that merited the award of an A grade in English. So we need to look back at our stats for English, and in English, the mean was 72 and the standard deviation was 10. So the mean was equals to 72 and the standard deviation was equals to 10. We will need those. Top 15% of students, so if I draw the curve, the top 15% of students would be in the upper half, so you're in the upper 15% basically, but definitely in the top half. So up here is where the top 15% of students are. So the area of that would be 0.15 for the top 15% of students. Now remember, on the Z values down here, zeros in the middle, this Z value right here is going to be a positive Z value. So what Z value leaves us with an area of 0.15 in the tail? If the area in the upper tail is 0.15, that means the area in the major part of it here will be 0.85. The 0.85 and the 0.15, of course, adding to 1. So the question is, what Z value separates 0.85, the bottom 85%, from the top 15%? So the log tables work with the bigger area. So 0.85 is the area I'm interested in. So I search my log tables for the closest thing to 0.85, and I see 0.8508 right here. So that Z value was a Z value 1.04. 1.04. So the Z value we know is 1.04. That's that Z value right there that separates the bottom 85% from the top 15%. Then we use our formula, Z equals X minus mu over sigma, to calculate X. We know Z, we know mu, we know sigma. So 1.04 equals X minus 72 over 10. Multiply both sides by 10, so 10.4 equals X minus 72. So 82.4 is equals to X. So the question said, find the least whole number mark that merited an A grade. So to get an A grade, you would have had to at least, so 82% wouldn't have been enough. We needed 82.4. So as a whole number, the answer is 80. You would have needed 83% in the test in order to be in the top 15%. Part 3, using the empirical rule or otherwise, estimate the percentage of students in the class who scored between 52 and 82 in the English test again. So we're sticking with the English test, which means we're sticking with the same mean and standard deviation. So I'll just calculate the Z value for each of those figures. So for 52, Z equals 52 minus 72 all over 10. So that's going to be minus 20 over 10, so that's going to be minus 2. Then I do it for 82, so Z equals 82 minus 72 all over 10. So 82 takes 72, 10 over 10, so that's going to be 1. So what we're really trying to do here is just calculate the area between minus 2 and 1. All right, we're just trying to calculate that shaded region in there. All right, that would be the percentage of students then, or the probability, and we can turn that into a percentage. So look, going to our log tables, we look up 1. We look up the Z value of 1 in the log tables, right? So we look up 1. You get 0.8413. 0.8413. So with the area from here all the way to the end is 0.8413. Now I don't want the area from here all the way to the end. I need to take away this area here. All right, so we're going to take away that area right there. So our answer, therefore, is going to be 0.8413 minus whatever that red area is. So to calculate that red area, I look up 2 as my Z value. So when you look up 2, you get 0.9772. 0.9772. So this area here must be 1 minus 0.9772. So therefore my answer is 0.8413 minus 1 minus 0.9772. And the answer to that is 0.8185. So estimate the percentage of students in the class who scored between 52 and 82. So as a percentage, just multiply that by 100. So that will give me 81.85%.